So for question 12, you're given a graph of a cubic function. You're given what the cubic is, y equals 2x cubed minus 17x squared plus 40x. You're told there's a minimum turning point at x is equal to k, and we want to show that the area of the region R, which is bound between 0, x equals 0, x equals k, and the x-axis there and the curve itself, we want to show that region R is 256 over 3. Now, if we're thinking of finding the area and we're given a curve, you should be thinking that we need to integrate. The problem is in order to integrate, we need to know what the two limits are. Now, we know what one of our limits is. Our lower limit is x equals 0, but we don't know what our upper limit is, our k value. So we're going to have to deal with that first. Fortunately, it tells us that we're trapped at when x equals k is at the minimum turning point. And if we've got a minimum turning point, that means that we need to differentiate. So dy by dx is equal to, if we differentiate, we have 2 times 3, which is 6, x drop the power by 1, which is 2, minus 17 times 2, which is 34, x dropping the power by 1 there, plus 40. So that's our differential. Now, because it is a minimum, so at this point, dy by dx is equal to 0. At any turning point, minimum or maximum, dy by dx is equal to 0. So we can make that equal to 0. Simplify this a little bit, we can divide everything by 2. So 3x squared minus 17x plus 20 is equal to 0. Now we need to solve this, and you could use the quadratic formula, you can complete the square, but actually the easiest way, factorise, or use your calculator if you can. So let's look if we factorise this then. At the start of one bracket, we must have 3x, at the other bracket, x. Because this is a plus sign, our signs are the same. And because this is a negative, they both must be negative. Factors of 20, which one must multiply the 3, and when we add them, the two numbers, we're going to get to minus 17. Well, we haven't got too many choices with 20, but ultimately we're going to need 5 and 4. So the 3 times the minus 4 gets us minus 12, minus another 5x is minus 17x, and just checking, minus 5 times minus 4 is indeed plus 20. So solving that then, we've got x equals 5 over 3, x is equal to 4. Now we've got two solutions. Well, we only really want one solution. Well, why have we got two solutions? Because this concept of dy by dx equals 0 is just for the turning point. Now that could be a minimum, maximum, could be a point of inflection as well, but as our cubic doesn't have a point of inflection, we don't need to worry about that. So our two values here must correspond, yes, one to the minimum, but one must also correspond to the maximum. Now, fortunately, we've got the graph, so it's quite easy to see that our maximum is further to the left, so it will be a smaller x value. Our minimum is further to the right, so it must be a bigger x value. So x equals 5 over 3 is the maximum. X equals 4 is the minimum. And from that, then, therefore, k must be equal to 4. So make sure you state that and make sure that's clearly going to be used. Now that we have our k value, we can deal with what we said to start with. We want to find the area of the region R. We're given the equation of the curve, so we can integrate to find the area under the curve. So to find area of R, we're going to integrate our function, so 2x cubed minus 17x squared plus 40x between our limits, our lower limit of 0 and our upper limit k there of 4 with respect to x. And then we apply our integration. Raise the power by 1, 4, divide by the new power, so we've really got a half x to the 4. Raise the power by 1, 3, divide by the new power, so minus 17 x cubed over 3. Raise the power by 1, so 2, divide by the new power, so plus 20 x squared for 0. Now this is a show that, so you can't just jump in and just substitute it all in and get the answer because they already give it you, so you need to show the working. Substitute the upper limit, so a half 4 to the power of 4 minus 17 4 cubed over 3 plus 20 times 4 squared, minus in the middle. Now for this last part you're substituting in 0. Now because all of these terms have 0 in, fine, that one's a nice easy one, we can put 0 there. 4 to the power of 4 is 256 times a half 128, 4 cubed 64 times the minus 17 over 3 minus 1088 over 3, 4 squared 16 times the 20 plus 320, and it's at this stage that we can indeed say that this is equal to 256 over 3. So therefore the area of R is 256 over 3. That is the minimum amount of working I would recommend showing if you want to guarantee yourself all of the marks in the exam.